morning, friends. We are going to start our discussion about the illustration. Right? Already we completed the theory of the chapter 10, mechanical properties of fluid. And also in illustration up to the 10.8 we also discuss. Now the next illustration is 10.9. On the basis of find out the coefficient of viscosity of a given liquid. Now here the one arrangement as shown in the figure is given. A metal block of area 0.1 meters square is connected to a 0.01 kg mass via string that pass over the ideal pulley as shown in a figure. Here the one metal block is placed on a horizontal surface. This block is tied to a string with a sphere of mass 0.01 kg. Right? A liquid with a film thickness of the 0.3 millimeter is placed between the block and the table. Now this block is placed on a liquid. This liquid has the thickness is 0.3 millimeter. Clear? Okay. The block moves to the right with a constant speed of 0.085 meter per second. As we release the block, sphere, what's happened? The block is moving to the right side with a constant speed. Speed is given 0.085 meter per second. In this situation, we have to find out the coefficient of viscosity of a liquid. How we find out the N for a given liquid? So here we are using the concept. First we are down. What are the data are given? The metal block of area is given. Area of a metal block. Capital A is given as 0.1 meters square. 0.1 meters square is connected to a string with a sphere of mass. Therefore, mass of a sphere. Mass of a sphere. M is given as 0.01 kg. Right? Via a string that passes over an ideal pulley. As shown in figure. A liquid with a film thickness of a film. There is the L. L is given as 0.3 millimeter. Convert into meter. Therefore, 0.3 into 10 is 2 minus 3 meter. That is the thickness of a film. Right? Okay. Now that is placed between the block and the table. Now the block moves with a constant speed 0.085 meter per second. Speed of a block V is given as 0.05 0.085 meter per second. Clear this? Okay. Find the coefficient of viscosity. Coefficient of viscosity. That means we need to find out the N. Now here what's happened? Between the two surfaces, surface of a block and table surface, the liquid of length L is initially present like to this way. That is the thickness of a liquid or the thickness of layer of a liquid. There is the surface of a block and that is the table. Okay. Now the block is tied with a sphere. As the sphere is going down, that means the weight force F is equal to mg, F in vertically downward direction. Therefore, the block is moving in this direction with velocity v. Now here, the laminar flow take place in a liquid between the surface of table and surface of a block. Due to the velocity of a block, now this film is formed in this shape. Therefore, the same strain is produced. Right? already we discussed the equation of the coefficient of viscosity on the base of the stress and strain. So coefficient of viscosity is the ratio of the saying stress to the strain rate. To the strain rate. For that purpose, first we have to find out what is the tension produced in a string or the force acting on a block. Therefore, the tension in a string P or the F is equal to mass into gravitational acceleration. Mass is 0.01. F is equal to 0.01. Value of gravitational acceleration is 9.8. Therefore, 9.8 into 10 is 2 minus 2 Newton. There is the force act on downward direction. This force acting on a block towards the right side. Therefore, the saying strain or the coefficient of viscosity is equal to the saying stress to the strain rate. Therefore, coefficient of viscosity N is equal to saying stress to the strain rate. How we find out the strain rate in this? For that purpose, the saying strain is equal to force per unit area, F upon A, for the force acting per area of a plate, upon the V upon L. Therefore, we can add the FL upon AV. All values are given. F already be obtained. That is the 9.8 into 10 is 2 minus 2. Thickness of a layer L is 0.3 into 10 is 2 minus 3. Upon area A is given 0.1. And speed of a block is 0.085. So as we simplify it, so we obtain 3.46 into 10 is 2 minus 3 Pascal into second. Pascal into second. There is the value of coefficient of viscosity of a given liquid. So here we directly apply this equation. Now the saying stress is equal to force per unit area or the force acting per unit cross-sectional area. But here the area is of a plate. On this plate, here the force is acting due to this weight force, the tension produced in a string in this direction. This tension acts on this area. So as a result, the block is moving on the right hand side with constant speed. Clear this thing? Okay. And now the strain rate, that means the strain, the change in length to the original length upon time, that is the strain rate. Right? Here we know that the strain is equal to change in length upon L divided by T. That is the strain rate, that is the strain, and strain rate is equal to divided by time. Therefore, delta L upon L into T, that is the velocity, so velocity upon length. That is the strain rate. Here this, okay. So very easy numerical, but here we have to knowledge of the equation. Right? Okay. Now after that the 10.10, the terminal velocity of a copper ball of radius 2 millimeter falling through the tank of oil at 20 degrees centigrade is 6.5 centimeter per second. Compute the viscosity of the oil. Here we also have to find out the coefficient of viscosity, and density of the oil is given 1.5 into 10 is to 3 kg per meter cube, and density of the copper is 8.9 into 10 is to 3 kg per meter cube. First we write down the data. The terminal velocity of a copper ball of radius of a ball. R is given as 2 millimeter. That means the 2 into 10 is to minus 3 meter. Right? Falling to the tank of oil at 20 degrees centigrade. Here the terminal velocity. Terminal velocity Vt is given as 6.5 centimeter per second. Convert into meter per second. So 6.5 into 10 is to minus 2 meter per second. Compute the viscosity of the oil. Density of the oil is given. Density of oil now. There is sigma is given as 1.5 into 10 is to 3 kg per meter cube. And density of the copper from which the sphere is formed or sphere is made. Therefore, density of copper material. Density of copper. There is our rho. Rho is given as 8.9 into 10 is to 3 kg per meter cube. We require the viscosity of the oil. That means the coefficient of viscosity. We require this n. So we have the equation of the coefficient of viscosity on the base of terminal velocity. N is equal to 2 by 9 r square g upon Vt, rho minus sigma. Therefore, the N is equal to 2 by 9 r square g upon Vt into rho minus sigma. Now substitute the value in this equation. So we obtain the coefficient of viscosity. Actually, there is the equation of terminal velocity of the ball in a liquid. Vt is equal to 2 by 9 r square g upon n rho minus rho 0 or the sigma. So here we substitute the value. Therefore 2 by 9. Radius is given as 2 into 10 is to minus 3 whole square g 9.8. Terminal velocity Vt 6.5 into 10 is to minus 2. Here rho minus sigma, rho is 8.9 into 10 is to 3 minus 1.5 into 10 is to 3. Therefore 2 by 9 square of the 2, 4. 10 is to minus 3, that means the 10 is to minus 6 upon 6.5 into 10 is to minus 2 into 9.8. Here 10 is to 3 is common. Therefore 8.9 minus 1.5. So as we simplify, we obtain the final answer is 9.9 into 10 is to minus 1 kg meter per second. Right? That is the kg meter per second, or the Pascal into second. And therefore 0.99 is the coefficient of viscosity of the oil. That is the kg meter per second. So where is numerical? Only we have to apply the equation and data are given. Clear? Okay. Now the next numerical is 10.12, 10.11 is cancelled. Right? Now in 10.12, the lower end of a capillary tube of diameter 2 millimeter is deep 8 centimeter below the surface of water in a beaker. What is the pressure required? What is the pressure required in a tube in order to blow a hemispherical bubble at the end in water? Now here what is the situation? Here in a beaker, one capillary is placed vertical. Right? Okay. Now listen. The capillary is deep in the water up to the edge depth. Edge is given, that is the 8 centimeter. That is the 8 centimeter. We want to get a bubble at the end of the capillary tube in a water. Diameter of a capillary is given. Now listen, diameter of a capillary is D is given as 2 millimeter. Therefore, radius of a capillary R is equal to D by 2. That means the 2 by 2, that means the 1 millimeter. Convert into meter, 10 is 2 minus 3 meter. That is the radius of a capillary. Now, the depth of a capillary is given as the H. That means the depth of the bubble. Depth of the bubble or capillary in water is given as H is equal to 8 centimeter. Therefore, 8 into 10 is 2 minus 2 meter. Surface tension of the water is given already as surface tension of a water, that is given as 7.3 into 10 is 2 minus 2 Newton per meter. That is given in a case. Now atmospheric pressure PA is given as 10 is to 1.01 into 10 is to 5 Pascal or the Newton per meter square. Density of water rho is given as 10 is to 3 kg per meter cube. And gravitational acceleration G is 9.8 meter per second square. Now, first we need to find out how much pressure difference is required. Pressure difference is required. Now here the gravitational acceleration G is 9.8 meter per second square. Here the A bubble is formed at the end of a capillary tube in a liquid. Here, first we have to find out the pressure difference between inside and outside of a bubble. Therefore, the pressure difference between inside and outside of bubble so we know that here the air bubble has the one phase surface, therefore Pi minus Po is equal to 2s upon R. Pi minus Po is equal to 2s upon R. That is our equation number 1. Now the end of the capillary tube is at H depth. Therefore, outside pressure Po is equal to atmospheric pressure plus the pressure due to the H column of liquid. Therefore, Pa plus H rho G. Now we substitute the value atmospheric pressure 1.01 into 10 is to 5 plus H 8 centimeter, 8 into 10 is to minus 2, rho 10 is to 3. That is the density of water, and gravitational acceleration is 9.8. Therefore, if we simplify 1.01 into 10 is to 5 plus 784. Therefore, 1.01784 Newton per meter square is the pressure of outside of an air bubble. Substitute this value in equation 1. In equation 1. Therefore, the PI from 1, PI is equal to PO plus 2S upon R. PO just we find out 1.01784 plus 2. Surface tension already given 7.3 into 10⁻² minus 2 upon radius 10⁻² minus 3. So let me simplify, we obtain 1.01784 plus 146. Therefore, 1.01930, that means the 1.02 into 10⁵ Newton per meter square. There is the axis pressure. And due to this axis pressure, at the end of the capillary tube, the air bubble is formed. So here the numerical of the illustration are completed. Now we start the numerical of exercise.